3 is going to make graphing a little easier. Instead of doing a full input-output chart, you can graph a linear equation or create a line by only using 2 points. Now, an easy way to do 2 points on a grid would be to find the x-intercept and the y-intercept. Now, I'm going to just switch back and forth here a little. You may need to pause and take a better look at this screen, but I'm going to explain it with the grid. So, if I'm going to have a point that is going to be an intercept or an, let's not make it white though, otherwise you're not going to see it at all. If I make a point right here, this is an intercept of the x-axis. Now, if I was going to label this point would be labeled, I went over 4, I write my x first, and I didn't go up and or down at all. That would be 4, 0. That is the x-intercept. There's a value for the x, and there is no value, or the value is 0, for the y. Now, the same would hold true if I did a point on the y-axis. Oops. Doesn't like when I use my pen on the iPad for that one. Let me get back to my point. All right. So, when I make that point, that is an intercept on the y-axis. So, if I needed to label that point, x would happen to be 0. I didn't go left or right at all. I only went down a negative, make that better, negative 6. I don't know if that's any better of a negative. There we go. Negative 6. So that point's 0, negative 6. So in the case of a y-intercept, having some problems writing on this one, maybe because of the grid. On a y-intercept, I have a value for y, and x is 0. For an x-intercept, one more time, I have a value for x, and my y is 0. Now, if this was going with an equation, you could see that I could then draw a line by just connecting 2 points. Well, the near miss of connecting 2 points. Magic of Mimeo, I can just change my lovely art here and make sure that it goes through both points. Well, we'll try it one more time. There we go. I lost my arrow here though. There we go. So, going back to the screen before that, we have to find the x-intercept. You're going to substitute 0 in for y. There is no value for y. You're staying right on the x-axis. And to find the y-intercept, you're going to substitute 0 in for x. You're not moving left or right. You're just going up or down on the y-axis. So, if I have an equation now, how does this work? If I have an equation, we're going to find the intercepts of the graph of 3x minus 2y equals 6. Now, because we're just finding the quick way with the intercepts, we do not have to put it into the function form. We can simply just substitute in. So, to find x, I'm going to put y in as 0. So, I would have 3x minus 2 times 0 equals 6. Now, simplifying that equation would simply be 3x equals 6. Divide both sides by 3, and I get x equals 2. So my intercept there, my x-intercept would be 2, 0. When x is 2, that was when y was 0. Now, to find, I guess I won't use green this time, I'll use white. To find my y-intercept, I'm going to put x in as 0. So 3 times 0 minus 2y equals 6. Simplifying that equation, 3 times 0 will be 0, so now I just have 2y equals 6, sorry, negative 2y. Divide by my negative 2 on both sides, and I end up with y equals a negative 3. So my y-intercept is going to be at 0. My x was 0. And when my x is 0, my y is at a negative 3. Now I can graph those. That's just brought over from the other side. And I can go ahead and I will put my point at 2, 0. So 2 on the x-axis, 0 for y. And this time 0 on the x-axis. And I'm going to go down a negative 3. And that then is the quick method to graph the equation that we started out with. And let me put that back on here. What we've just done is we've graphed the equation 3x minus 2y equals 6. Now, to fully understand why we are graphing, we have graphed all the different solutions. So if I was going to substitute in 1 for x, this is what I would get for my y. If I was going to, and we can keep doing this, this is giving me all the solutions for this, for this linear equation. We are finding all the coordinate pairs that will make that a true statement, as we did in lesson 8.2 when we were testing coordinate, when we were testing coordinate points. Those were coordinate pairs there. That is what we have now. The line is now showing us all the coordinate pairs that would match or that would solve this or make this a true statement, the x's and the y's that would make this a true statement. So when we are writing and graphing an equation, we're going to look at, you are canoeing along a 12-mile stretch of river. You travel 4 miles per hour when paddling and 2 miles per hour when drifting. Write and graph an equation describing your possible paddling and drifting times for the trip. Give 3 possible combinations of paddling and drifting. So we're going to let x be the paddling. So if I look at x here, it tells me 4 miles per hour. So my rate is 4. So it's going to be 4 times the amount of time, the hours I'm going to be paddling. My drifting time is at 2 miles per hour. So the rate is 2 for every hour that I'm drifting. And we want to get to 12 miles total. So 4 miles per hour of paddling plus 2 miles per hour of drifting is going to take me to the total distance of 12 miles. So what we're going to do is do a quick graph again here. And we're going to put in our 0 for our x. So that gives me 4x equals 12. I'm going to go ahead and put some other details in here just so you can follow along. So I need to solve for my single x. So I'm dividing both sides by 4. So I have x equals 3. So my first coordinate point then would be 3, 0, which is my x-intercept. For my next one, I'm going to put, by my y-intercept, I'm going to put x in as 0. So I would get, simplifying it as 2y equals 12, dividing both sides by 2, I would get y equals 6. So now 0, 6 is my y-intercept. Okay? Let me just get rid of those. I'm not sure why those are even there. Okay. So if I go ahead and it said to find several solutions, I'm going to go ahead and I am going to graph that just by my two intercepts. Let me get to the right tool here. So my 3, 0 is my x-intercept. I go over 3 into 0. And my y-intercept is 0, 6. Now I will tell you, in real life situations, when we're graphing real life, we really only need this coordinate plane right here, because we can't do it for a negative amount of time and we can't go a negative distance. So this would be like you do in science class. We're going to go ahead and we're going to have our results just in a regular graph, just an XY axis. We don't need it to be in the coordinate planes. So I have, this is my solution. So now it says, give 3 possible combinations of paddling. So we already have, if we paddle for 3 hours, we're going to then drift for 0 amount of time. Or if we just simply drift for 6 hours, we don't have to paddle at all. Now I'm going to look for another perfect intersection point. So I find one more right here. Now this is telling me, remember my X is my paddling. So this tells me if I paddle for 1 hour, I could actually drift for 4 hours and still make it 12 miles. So there's going to be 3 answers or 3 possible answers here. And we can write them as coordinate points. The other ones are written as coordinate points. But knowing that our X value is how far we're going to paddle, and our Y is going to be then how far we can drift. Okay. And I believe, let me just look in the book here, I think that is our last example. That is our last example for using intercepts. That concludes lesson 8.3.